All right. Good evening, good morning, good afternoon to you, wherever you are. I'm Gloria. I'm part of the Get Coin team. I'm here with Kevin in York, and I before we get started, I wanted to go over a little bit of housekeeping. First and foremost, the session's being recorded, so you'll be able to watch this session and all the sessions in this hackathon under the Illuminate 22 hack playlist on the Get Coin Media page. With that too, if you do have any questions, feel free to say your questions in the chat or in the Q&A. I will be monitoring both. If you're watching on YouTube, you can just drop it in the chat there. I'll make sure your question gets answered. Last but not least, in the chat, feel free to say hi. Let us know who you are and what you're working on. It's a great way for us to get to know y'all, and a good way for y'all to get to know one another. With that, I'll go ahead and hand it over to you, Kevin, and we can get started.
Thank you so much, Gloria. And thanks everyone for joining us this morning or afternoon for the second workshop of Illuminate Hackathon. We had the full Illuminate conference last week, and hopefully you were feeling a bit inspired. And so now we have some technical hands-on workshops today hosted by Hyperlane. So today I have the pleasure of introducing York Rhodes, who's founding engineer at Hyperlane. And Hyperlane is the modular interoperability platform. And with Hyperlane, you can build interchain applications or apps that can communicate between any different blockchain, and you can serve users wherever they are. The goal of the Illuminate Hackathon is to encourage you to try out a connected contracts approach and use a general message passing protocol to build an application that is multi-chain and that is connected. So today you're going to learn all about that with the help of Hyperlane. So with that, I'll go ahead and hand it over to you, York.
Awesome. Yeah, thanks, Kevin, so much for the intro. Let me just share my screen and then we can jump right in. Okay. Cool. So everyone should be able to see the slides and hear me. Kevin, if you can give me a verbal.
Yeah, perfect.
Okay.
Yeah,
sweet.
It looks good.
Right. So like Kevin said, I can speed through this, but it gave me a great intro. Hyperlane is a developer platform for building interchain applications. And we have some smart contract APIs that let you send messages between blockchains. We're specifically focused on low latency guarantees for these APIs to try and provide the best user experience possible. I think, like, obviously while maintaining some amount of security, we make some kind of novel trade-offs there that I encourage you to read more about in our docs. But this workshop will be focused mostly on kind of the what the APIs enable rather than their underlying security models. So why should you care? I think people probably in this forum understand that choosing a specific blockchain has all these consequences. Moonbeam is doing a great job at exploring kind of different trade-offs from maybe other networks. And I think right now application developers are faced with this problem of deciding upfront where they want to commit basically in perpetuity. So there's like implications on developer experience, user experience. You have some kind of like platform risk or being able to migrate away from a platform if it at some point departs from your expectations. And then I think the kind of most important decision is what is the actual demographic of users that are on that chain, and what type of network effects or composability are you going to have with other applications within that ecosystem. So these are all choices that are really difficult and kind of nebulous to evaluate. And when application developers go cross-chain today, they typically deploy an entirely new instance on one of these new chains. And the network effects of these applications are limited to the specific chain that they're deployed on, because it's just the way the applications are designed. So in comes Hyperlane. Hyperlane eliminates this choice for developers. So instead of choosing one chain to deploy on, or kind of deploying separate instances on a bunch of chains, you can build an interchain application, like Kevin so eloquently described. And Hyperlane is really this network between blockchains that provides this connective tissue and allows you to build these types of applications. So instead of being kind of constrained to the specific demographic that's on a specific chain, you can actually access all of these different networks and user demographics. And you can bring your application to your users, to your target users, without requiring them to use some third-party application to bridge or to even get access to your app. And just kind of some nice things we've done for the developer experience here to reduce the overhead of actually understanding how to build one of these applications. But yeah, I think the takeaway is no longer do you have to kind of commit to a specific chain. You can become chain agnostic as an application developer. So we're big advocates of that at Hyperlane. I think a lot of us struggle to even understand some of the trade-offs that some of these different infrastructure layers are making, but obviously they lead to kind of high variance in the user demographics. And so we just want to bring our application to all of those users. So what does it mean to build with Hyperlane? Today, we're going to talk through 4 different kind of on-chain smart contract APIs that are accessible to you. There is also off-chain tooling available, but these are kind of like the core products that we want to talk about today. So first and foremost is what we call the messaging API, which is really what everything is built on top of when you're using Hyperlane. So to send a message between 2 blockchains, on the sending side, you need to call a function on the outbox, which is a Hyperlane contract called dispatch. You need to provide the destination chain identifier, as well as an address on that chain and the message to be passed to that recipient. And then kind of symmetrically on the receiving chain, you need to have a contract which implements this specific interface called iMessageRecipient, which has a single function on it called handle that basically receives the origin chain identifier, the sender address, which made this call to the outbox, and the message that was passed. So yeah, the crucial thing to note here kind of is that this recipient, as passed to the dispatch call, must implement this interface. And definitely check out the docs for kind of more detailed usage of this API. I don't know what the slide is. I think one of my colleagues added this, maybe made a joke here. Cool. So yeah, what's nice about the messaging API is that there's no constraints on what the messages can be. So it can just be arbitrary bytes. And as an application developer, that's really flexible for you. You can basically define your own message encoding. There's no encoding enforced by the protocol. And that's something that we really prioritize, is like having this developer experience, just really being flexible. So the kind of caveat to that is that application specific features, like if you want to do a token transfer or a swap, or you want to perform some action and encode it into this message, the message recipient needs to implement that logic in a way that's application specific. So this like recipient contract that you deploy on the destination chain has to go and decode that message encoding and then go do whatever corresponding actions. And so what kind of another, I guess, API that's available in the toolbox is something we call Interchain accounts, which basically allows a smart contract on one chain to securely control an account on another chain. It's almost like a proxy account. And what's nice about this is the interface doesn't require the recipient to implement message that iMessage recipient handle function anymore. Now we can use this interchain accounts API, and we can dispatch an action. Could be like an ABI encoded call, for example, to a recipient address on the destination chain. And the recipient no longer needs to implement that specific interface because we actually make the call directly from the sender's interchain account. I do actually have some diagrams that let me pull something up really quickly just to illustrate. 1 second. I know this is a bit distracting. Story is currently writing a bit of an announcement post about these new features, but there's a nice diagram here, which basically illustrates the beauty of this interchain accounts API. So you actually, instead of having to implement a specific interface on the destination chain as a developer, as well as deploy that contract and manage deployments across multiple chains, you can just deploy a single contract on the origin chain, which uses this interchain accounts API. And your call will be relayed from one of these proxy interchain accounts. And only your sending contract can make those relayed calls. So yeah, it's basically a way for you to kind of get access to like this concept of interchain composability between contracts. Without this, and again, the reason why this is nice is the application-specific handlers like token transfer handler or swap handler or staking handler. It's actually quite complex to implement because you want to allow the sender on the source chain to have like, you want to be able to distinguish between the sender on the source chain of, let's say, a token transfer. If I'm transferring from one address to another chain, I need to be able to distinguish between those senders. And this property of creating this like proxy account that's basically controlled by the origin chain account, and only that account allows you to differentiate origin chain senders. So a kind of illustrative use case of this API is in cross-chain governance, which we've seen kind of a lot of demand for as DAOs expand to new chains. So using the interchain accounts API, you can basically compute on any chain what the corresponding interchain account is for an origin account. And so in this case, if we wanted to compute a DAO's interchain account, we would provide that DAO's address and the chain identify where that DAO exists or originates. And what this allows you to do is on a chain that a DAO is not even on, you can now permission actions that only that DAO on some other chain can kick off or can dispatch to your contract. This is kind of just like a nice illustration of what's possible. I think we've also seen what's nice about interchain accounts is basically asset custody. So instead of using some asset bridge where you are holding a synthetic representation of an asset, you can actually use interchain accounts to custody the asset remotely, even as a smart contract without introducing some kind of like operational overhead of custodying that. You can instead just like, use the interchain accounts API to move around those assets without ever interacting with an asset bridge. And obviously, or maybe not so obvious, but asset bridges are notorious for suffering from a lot of, there's just a large attack surface area, and they tend to attract a lot of attention from attackers. And so this is a nice way to avoid that problem entirely. Instead of having some like asset bridge, which is custodying everyone's assets, you actually have like account. It's almost like a form of account abstraction on another chain that's custodying your assets. So there's like a bit of fault isolation there. So I guess moving beyond interchain accounts, another kind of use case that we've identified a lot of people asking for or trying to understand how to implement with the messaging API is basically reading remote contract state. So if interchain accounts lets you easily write to remote contracts in a way that distinguishes between source chain message senders, interchain queries allows you to read from remote contract state in a way that's kind of abstracts away a lot of complexity. So it is possible with the messaging API to read from remote contract state, where you basically do a dispatch in one direction and then receive, and then in that same transaction, do a dispatch back and receive. It requires you to kind of implement sending and receiving on both sides, and it's can be a little confusing for developers to use this API, and it's cumbersome. So we introduced this API called Interchain Queries API, which abstracts away this ability to basically make a remote view call on another chain. So here's what the interface looks like. Basically allows you to send a query to a destination chain, as well as a ABI encoded call to a specific address. And then what we call a callback, which I'm happy to kind of elaborate on. But again, what's nice about this interface is you as a developer don't need to worry about deploying contracts or implementing contracts on the remote chain that you want to read state from. You just use this API and everything else is managed by Hyperlane. So an example here is querying ENS. So let's say you're on Moonbeam and you want to go look up basically the owner of the Hyperlane domain on ENS on Ethereum and use that value on Moonbeam. You can do that really easily with this API. So you just call query on the API contracts, target the Ethereum domain, you construct one of these owner calls, and then we do actually need to provide a function selector which specifies where the return value should be processed on the way back, so on the like kind of return from the query. And so in this case, we would pass a function that accepts the return type of owner. So if the return type of owner is address, then we need to provide a function which will accept that type. And so again, this gives developers kind of a nice primitive for interchain composability. I again have some nice diagrams for this. So again, as a developer, you just call this API on the chain that you're on or where you've deployed contracts, call query. The Hyperlane API does a bunch of stuff to relay. It makes the call to the target recipient and then gets the return value of your query, relays it back, and then calls into your contracts. It calls the callback selector that you provided. So like this article says here, like this kind of generalizes the call opcode to be interchain, which I I think we've found has been fairly accessible, or it's like a nice mental model to think about how to use this. Okay, so I can take questions now on what I presented so far, and then what I wanted to do is hop into actually trying to do like a live demo of these things to show you that they actually work, and how easy it is. So if there's any questions, happy to take those now.
I have a quick question, if that's okay.
Yeah, of course.
I love the part about the interchain round trip accounts, because I think that's a really I think that's a major question that people have when they first look at building a cross-chain app. So my only question is just where can people find this once it's published? Once the blog post is published?
Yeah, so the blog post will be on our Hyperlane Medium, which is basically everything is accessible from this Hyperlane XYZ domain. I recommend probably people look at the docs. I haven't updated the docs yet with the diagrams, but I'm probably going to do that right after this workshop. So yeah, docs is probably the primary resource I recommend. And yeah, I'm actually like, my plan was to go through the quick starts of these APIs, which so basically just like follow along with the docs to demonstrate that like actually all of these systems are live on Moonbeam, and we can do some like test transactions. What do you think?
That sounds amazing.
Cool.
Let's see. I don't see any questions on the chat. Feel free to drop any questions there.
Yeah, and there's no questions on the YouTube either, York, so you can continue forward if you would like.
Okay, awesome. Yeah, so maybe a few things. Also, you guys can still see the screen, right? I think so.
Yep, got it.
Maybe a few things to call out before I jump into kind of like the live demo, is a concept of interchain gas. So I didn't want to cover this in the workshop because it's like a bit distracting. But eventually we are going to migrate to a model where people need to pay for the gas costs of transactions which land on the destination chain in the kind of atomically with the source chain transaction that they're sending a message in. So this is just something to look out for. Not something that we need to cover right now, but and is not required right now. So right now we're subsidizing basically the destination chain gas costs. But yeah, something to look out for if you do decide to end up building on top of Hyperlane. Also, something I didn't touch on in the workshop is this Token Bridge API. This is kind of actively in development, but the basic concept is this is like another abstraction to allow you to move value between chains. So that includes things like USDC, as well as eventually your own asset. If you're an asset issuer and you want to use Hyperlane to move value around between chains, this is the resource for you. And again, this will all be updated very soon with kind of work in progress. Okay, awesome. So I'm gonna hop into the quick starts just to kind of make this feel a little more tangible. And you guys could definitely, like, I'd encourage you to follow along or try following along if you can do that. So yeah, what should we do? Okay. So I think we should send a message first using the messaging API from some network to Moonbase Alpha, to Moonbeam's testnet. So let me try doing that. Oh, also, I don't know if you can see, you probably can't see that window, huh? One sec.
No, we can. We can see.
You can see the terminal?
Yep, perfect.
Oh, great. Okay. So I, right before this workshop, set up a, actually, I don't even want to be in this repo because you don't need to have the repo installed to do this. Okay. So right before the workshop, I fauceted an account, a fresh account on the Goerli network, got 5 Ether. This is super easy. Just go to one of these Goerli faucets, throw your address in. Yeah, it's not a difficult process. We need, obviously, some funds to be able to send a transaction. So what I'm going to do is send a message from Goerli to Moonbase Alpha. So we're going to use the cast command. Cast is a part of the Foundry toolkit. Definitely recommend checking that out. But it basically provides us a nice like CLI for like sending transactions. So as well as a bunch of other stuff. So the outbox address on Goerli, I'm going to go to Goerli, grab the address, and save it. Then we're going to get the destination domain, which is going to be Moonbase Alpha. And then we want to get a recipient. So because we're using the messaging API, we need a recipient that implements the iMessage recipient interface and that handle function, like I was describing before. Luckily, we have some test recipients that are already deployed, so we don't have to deploy a new one for the quick start. I believe we can just grab this right here. So recipient. And then RPC URL. Let's see, Goerli, public RPC. Goerli, we can get this guy right here. Okay, and now we should be able to do our transaction. Let's see if this works. Okay, and what message do you guys want to send? So we can say, hi, Moonbase from Goerli. Work on Goerli. Cool. And then I'm using this like dummy private key. That's the address I funded. Feel free to steal my funds after. It looks like the RPC is down. Classic. Let me just try. If the public ones don't work, we have some private ones I can use. Okay, yeah, that one's definitely not working. You can try and use this guy's. We'll see if that works. Okay, it does seem to work. Let's try that again. Gas required exceeds allowance. Okay. That is not good. Let me check the balance. balance of my address. Oh, whoops. RPC URL. Ah, okay. So apparently I don't have any balance on that address. It's possible someone stole my balance. Okay, let me try funding it again. I thought I already did that. Let me just make sure I'm looking at the same one. 1479. Ah, okay. Seems like a lot of people use this address. 7 minutes ago. Looks like someone took my ether. All right. Let me use a different private key then. Sorry about that. Ooh, I'm gonna need to get the public key from that. Is there a key command here? This is classic live demo stuff. Okay, I don't see a, oh, maybe wallet. Cast wallet. Oh, let me do that. It's much better. Okay. Faucets. Let's try that. Uh-oh. Uh-oh. I think I'm getting rate limited. Another classic.
If you drop the address in the chat, I can try to use a different faucet.
Okay, thank you. Yeah, worst case, like I said, I have some addresses which are private you can use. Yeah, and if you need the URL, that's the one I'm using. It does require Alchemy authentication.
Here, it went through. I used Paradigm's multi-faucet.
Oh, perfect. And that one has Gorley.
It's supposed to.
Okay. Let's see. Okay. Yeah, I have some ether there.
Cool.
All right. So yeah, I just need to update these guys. Private key is going to be this one. And then address is this guy. Just want to make sure that looks good. Oh, see, why is that not showing anything? Is it possible that the RPC is bugged? I think it definitely is. Okay, I need a better RPC. You know, you'd think this would be a little easier, but here we are. Gorley testnet. All right, this one seems to be working. Let's try that. Okay, got one. All right, where were we? We were doing cast, send. We'll get some kids in the background here. Cast, send from private key. I think that looks good. So we are currently sending from the Gorley network to the test recipient on Moonbase Alpha. And looks like we got a successful transaction on the source chain. So we're going to use our handy dandy message explorer, which has been getting a lot of love recently, to look for that transaction. Is that the right thing? Yeah, transaction hash, not found yet. Let me just see this. Okay. Oh, there we go. So, yeah, this shows the different phases of message processing. So it shows us when we dispatch the message from Goerli, there's a finality period that we have to wait. Our validators on Goerli have signed the message, and now we are relaying it to Moonbase Alpha. So as soon as that transaction lands on Moonbase, I'll go check it out on the other Explorer. Yeah, I believe this is our message. It's just encoded weirdly. So I think Moonbase's Explorer will be able to decode it nicely. Awesome. So message got delivered. Let's check it out. So if we look in the logs, look at that. We'll see the message that we passed from Goerli emitted on a contract on Moonbase. So you can see, system actually works pretty fast. It's got some nice observability tooling. Glad we were able to do that. All right, now I wanted to jump into using the accounts API. This is going to look a little similar, but we're actually going to change the API address that we're using from the outbox to some contract that I guess we're calling the Interchain account router. Really, you don't need to know much about that, just that there's a different address. Let's try to do this. I think the address is the same on every network, which is why it looks like that. All right, so I believe I need to change the recipient to be some contract that we know a function to call on. I guess there is this contract right here. Let's check that out. All right, so this is a test recipient. Looks like we can call some function foobar with a message and an amount. So I'm gonna set the recipient. Okay, it is the same, so I don't need to change it. Just make sure. Yep. Okay. So we don't need to change the recipient. We just need to. What do we need to do? Destination domain, cast call data, hello world from my ICA via cast. I actually don't think we need to change anything. So look at that. Failed to parse tokens. All right. Let's see what the problem is. Might be something to do with this cast call data foobar thing. So let me pull that out. Invalid data. Okay. Interesting. Why is that not working? Not sure why that's not working. If someone sees something that I'm doing that's dumb, please call it out. Maybe with the space. No. Function signature in the form name types. Pretty sure I've done this before, so it's a little surprising. Oh, I see what I did wrong. Sorry. I need to pass the arguments. Okay. There we go. So this is so if we remember, we looked at the Interchain Accounts API. This is the API encoded call that we're putting in the data parameter. So let me just save that. And then we have cast, send, dispatch, destination domain, recipients. So I think all this stuff can just make call data. Not sure why there's parentheses there. I think that might be wrong. Dispatch 32 address bytes. Oh, I see now why there's parentheses. Okay. Invalid data. Great. Okay. Not sure what's going on there. It's, again, more classic live demo stuff. Give me one sec.
In the meantime, I can talk about some of the bounties, if that's okay.
That would be great. Thank you so much, Kevin.
Awesome.
Let me debug this.
So, as everyone may know, each sponsor of the Illuminate Hackathon has put forward some bounties. So Hyperlane has 10 in total, 10 prizes, which is very exciting to see. And they're super attractive prizes and bounty challenges. So the top prize is a $5,000 best use of Hyperlane, best use of Hyperlane's Interchain API. To win this prize, you simply need to build an app that utilizes Hyperchain API to establish interchain connectivity. You could be sending messages, you could be sending assets, you could be making cross-chain calls to view data or oracleize data between blockchains. There's a lot that you can do, and so this is a pretty wide open bounty. One suggestion here is that if you're shooting for this top prize, that maybe you want to try something a bit more complex and built out. Maybe you want to make an interchain compound or an interchain swapping protocol, so you can swap assets across chain. Not just send assets across chain, but for example, let's say you're on Moonbeam and let's say you want to make a swap on Ethereum. You can direct that action to take place from Moonbeam. You can send the message via Hyperlane, and then you can have that swap take place on Ethereum. And as you learn, about the round trip calls, you could perhaps take another action back on Moonbeam, or perhaps you just tell the user to look at this link in the Explorer, or you can have your UI update once the swap is done. So next one is the best use of Hyperlane, particularly related to DeFi. There are 2 prizes of $2,000 here. And there are plenty of DeFi-related sample ideas. So for one is to use the Accounts API to create an app that allows interchain swaps without having to deploy any contracts on remote chains. So this is really cool. Let's break that down a little bit, right? You can use Hyperlane and you can use Moonbeam to send a message to another chain. So let's say, again, Moonbeam to Ethereum. And you can use existing deployed apps on Ethereum. You don't have to create anything new from scratch. All you're doing is directing an action to take place. So you're specifying what contract on Ethereum you want to interact with. You're specifying call data. So what is the asset that you want to swap? What are the slippage parameters, the deadline, all that. Your account still has to meet all the parameters that you need in order to make the swap. You need to have the right asset. You need to have everything set up there. But that could be quite cool. You could do an interchain stable swap. You could accept deposits on different chains, and you could create unified or cross-chain liquidity pools. You could create an interchain lending app, allowing borrowers to borrow against collateral from a remote chain. Very cool. You could create a contract that allows you to control multiple safes or DAOs on remote chains. Wow, this is something, very cool. Using interchain accounts, you could do this without having to deploy additional logic on the receiving chains. So that's the DeFi sample apps. Next one is NFT related best use of Hyperlane. So you could create an interchain minting contract that acts as a load balancer between chains. Let's say you're having an NFT mint, which is driving a huge amount of activity to a particular chain. Let's say you need to offload some of that to another chain that perhaps has some open block space. That's definitely something to consider. You could also create an interchain NFT collection where the NFTs have different properties based on the chain that they're currently on. So you can move the NFTs around from chain to chain, and then perhaps they absorb or inherit, different properties based on the chain that they're on. We also have best use of Hyperlane for infrastructure, governance, or gaming. This is also 2 prizes of $2,000 each. And the idea here is to build infrastructure for Hyperlane or for apps that use Hyperlane. And there are a couple examples here. I won't go through them all. But of course, a game, of course, is very popular. Gaming-related infrastructure also is eligible. So there are 3 $1,000 prizes here. The first one is best use of interchain queries. Builds an interchain application which utilizes interchain queries via the Hyperlane Queries API. The next one is best use of interchain accounts. So builds an interchain application or use an existing one, take an existing one and use the Hyperlane accounts API. The idea here is that the application's core functionality, cannot be completed, without the use of Hyperlane's Queries API. So it does have to be a main component in the application. And the last one here is best use of the liquidity API, and this is $1,000. So there's a lot of opportunities here, and thank you so much to John, and thank you so much to York for putting all these bounties together. There's a lot of documentation here, a lot of resources, and this is, absolutely something to check out.
Yeah, thanks so much, Kevin. Super appreciate the overview there. I think what I realized is happening, the cast command that we're using to encode the tuples that are passed to the Interchain Accounts API actually does not support encoding those tuples properly, like the cast send command. So if people are trying the quick start out right now, because for now I would recommend using the I guess browser version of things. I wanted to use cast just to kind of like get a little closer to what developers are doing, I think. But yeah, you can also do this directly from your browser, just using MetaMask and interacting through Etherscan. You'll see kind of like the tuple encoding is a little bit janky in some of these interfaces. So apparently Cast doesn't support. I'm gonna go in and fix that. Classic live demo stuff. You're just gonna have to trust me that that works. I think for the queries, let's see. For the queries, I think we won't have that problem. So I'm going to try just to show you that we can actually make a call. Also, Kevin, I don't know if you know of any contracts on Moonbase that it would be cool to read from. Let me know if
Certainly,
you
I
have any ideas.
can find one. Are you thinking of like an Oracle? There's some Oracle ones.
Yeah, that would be great. Assuming that there's like a function that's fairly easy to call.
Yeah, totally. So for Moonbase Alpha, let's get the KSM to USD price feed. So that would be this one right here. So here's the contract address, and then let me just get the contract interfaces here. Yeah. So the interface is, if you just search for fetch price data on that page, you'll see. And if we need a verified contract, I can try to find one that's verified if that's an issue.
No, I don't think so. So I'm going to use this latest round data one. We'll see. Oh, just thinking. We might not have. I think we might not have a function on the source chain that will accept this return type for the query. Let me just try one of these other ones to see, like I can get a description or something like that, just because I don't want to deploy a contract right now.
Sure.
So yeah, handle query address result. What does that accept? An address. All right. Well, maybe that's not the most useful for this. Yeah, let me just check if that test query sender has any other. Okay, cool. I do have some other ones. So I can try. Let's see what we have here. Okay, I mean, I can try getting the version. I don't know if that'll be very exciting. But
that's perfect. That's fine.
All right. Yeah, for now we'll do that. So that will, because that's a UN256, we'll need to adjust the call slightly. Oh yeah, it looks like these docs just haven't been updated properly. Okay. All right, we're doing it live. I got a few minutes here, and then I'll let you guys get on to the next presenter. Okay. So we have this test query sender on Goerli. We want to query a UN256. So we're going to take this address and we're going to query UN256. And then that's a UN32, an address and bytes. And then the recipient is going to be the address you gave me. Okay, yeah, UN32 is destination domain, and then address is recipients, and then we need to make the call data. So let me try that version. I think that should just work. Okay. Let me just make sure the recipient is correct. Cross my fingers. Seems like something's happening. Amazing. Okay. Yeah, I just got to update the interchain accounts example. All right. So again, we can throw in the transaction hash to our Explorer. It takes a second for it to index. You know, performance enhancements coming soon. Hopefully it shows up in a second here. We're also working on a REST API for this Explorer. So you can actually use this in your front-end applications to surface relevant information to your users on message delivery. Okay, sweet. So we have a message being sent. Uh-oh. Status failing. That's not good. Processing response body. Revert multi-call. Call failed. Okay, it's possible that I messed up the call data. I think it's actually pretty likely. So let's see what I passed in there. Oh. I think I need to also pass the, didn't follow my own advice. So I think this target data is, where did I put the merchant query? Also, sorry if there's a lot of background noise.
No worries, we can still hear you fine.
Okay, yeah, just looking for this source code. Under query address. Okay. To target data. And then handle query address result selector. Okay, so what did I use? Query UN256, UN32, address target, bytes. Oh, you know what we should do? We should look at the source chain transaction. Okay, so we dispatched the query to, oh, I see. Okay, so this is the Moonbase alpha domain, and that's the sender. Okay. It's a little annoying. This isn't decoding. Yeah, I think my target data looks wrong. Where are you in 256? Cast call data version. I don't know why I passed in all that stuff. It might be padding to 32. Where did I put the target data? Huh. Okay. Yeah, I know we're at time. Obviously ran into some hiccups with the live demo, but yeah, we're working on smoothing all this out. Obviously, there's a bunch of docs and kind of like debugging tooling available, as you've seen. I think it was a little ambitious for me to try and do a contract I haven't interacted with before, but you know, you live and you learn.
All good, York. We'd much rather see, you know, a live demo, you know, in progress than no live demo at all. So very grateful for you being here today and putting on this workshop.
Of course, yeah. Thanks so much, guys, for coming. Definitely reach out if you do end up working on Hyperlane in the hackathon. We're also available pretty much 24/7. We have people in a bunch of time zones on Discord. If you need some like pair programming help or something along those lines, we're definitely available for that. So yeah, good luck with the hackathon. I think you know all the prizes. Kevin did a great job giving an overview there. And yeah, try out some of these new APIs. Give us some feedback. Let us know if something doesn't work. And yeah, love to hear from you.
Thank you so much, York. And if you haven't joined our Discord yet, be sure to join us at discord.gg/moonbeam. We're going to be setting up some office hours starting next week, and then week 3 and week 4. York or somebody from Hyperlane will probably join us for week 3 and 4. And I think that's it. Yeah, if you haven't registered yet, gitcoin.co/illuminate. Gitcoin.co/hackathon/illuminate. Let me put the link here. Oops. There we go.
Great.
Yeah, thank you so much to York for doing this. I always think it's really helpful when people still do get stuck because it shows like how people, even within the industry, try to work their way out of it. And so having a contract that you've never interacted with and like showing the steps that you used was really insightful. So kudos to you for that. Join us for the next session, and we'll be listing it on Discord. It's tomorrow, same time, same channel. But other than that, we'll see you all later.
Thank you so much. And as Gloria mentioned, yep, tomorrow is the Moonbeam workshop. So I'll be leading that. Yeah, same time, same place. Yeah, thank you so much.
Yeah. All right. See y'all then.
See.
Bye, everybody.